Hello students, welcome. Previously, lesson 14, form 2 topic 2, we were dealing with the chemical properties of halogens and the uses of halogens. So today, lesson 15, we want to proceed to the last chemical family, which is the noble gases. So we start by knowing what noble gases are, and we are saying these are group 8 elements of the periodic table. Remember learners, we have done the first family, which was alkali metal, and we said alkali metals are group 1 elements of the periodic table. Then we have done alkali and earth metal, and we said these are group 2 elements of the periodic table. Next, we have done halogens. We said halogens are group 7 elements of the periodic table. So if we are asked what are the noble gases, we say these are group 8 elements of the periodic table. So the noble gases are found as free gaseous elements in nature and form about 1% of air. So next, let's know what are the members of the noble gases. And we're saying members of the noble gases include helium, neon, argon, krypton, xenon, and also radon. And we're saying argon is the most abundant and forms about 0.9% of air by volume. So when we see the periodic table, we said it consists of 7 periods and 8 groups. So we have group 1, group 2, group 3, group 4, group 5, group 6, group 7, and this is group 8, which we sometimes refer to as group 0 because they don't gain nor lose electrons. So the members include, we said, helium, neon, argon, krypton, xenon, and also radon. So next we are saying the electron arrangements or configurations of the first 3 members of the noble gases is as follows. So we have here helium, neon, argon with the electronic configuration of 2, 2, 8, and 2, 8, 8. So we see with the exception of helium, the other members of the noble gases have 8 electrons in their outermost energy level. And if we're asked what do members of the noble gases have in common, we are going to say with the exception of helium, the other members of the noble gases have 8 electrons in their outermost energy level. So this is the atomic structure of helium atom, neon atom, and also argon atom. So we are saying with the exception of helium, the other members of the noble gases have 8 electrons in their outermost energy levels. Down the group, there is an increase in the number of occupied energy levels. That means when you are dealing with helium, we have only 1 occupied energy level. When we are talking about neon, we are having 2 occupied energy levels. When we are talking about argon, we have 3 occupied energy levels. So as we move down the group, the number of occupied energy levels increases by 1. So next we are saying helium with only 2 electrons has 1 occupied energy levels, which is full, hence has a doublet electronic configuration. For example, if we see an element with this electronic configuration, we can say that it has a doublet electronic configuration. So we are saying neon and also argon have 8 electrons in their outermost energy levels, which is full, hence has an octet electronic configuration or electronic arrangement. So if we have your last energy level, which is 8, which is full, that means we are going to say you have octet electronic configuration like neon and also argon. So you're saying under normal conditions, noble gases neither react nor lose electrons. They are stable and unreactive or non-reactive. So next we are going to proceed to the physical properties of the noble gases. Here we have the table showing the physical properties of the noble gases. We have the elements or the members of the noble gases here, their chemical symbol, we have their atomic number, their atomic radius, their fast ionization energy, their melting and also boiling points. So when we see the table, we are going to see the atomic radius, which is increasing down the group, the ionization energy, which decreases down the group, and the melting and the boiling point, which increases down the group. So we are going to say group 8 elements are colorless and odorless gases. They have no color and no smell. And we're saying they are monatomic gases as they exist as single atoms. They are non-combustible and non-poisonous gases. The atomic radii of the noble gases increases down the group, and we're seeing this due to the increase in the number of occupied energy levels. Remember, learners, we have seen the atomic radii and the ionic radii of alkali metal, alkaline earth metal, and also the halogens. So all of them, we were just seeing the same trend. That's The atomic and the ionic radii of alkaline earth metal and also the halogens were increasing down the group, and the reason was due to the increase in the number of occupied energy levels. Just like those families, even the noble gases, the atomic radii increases down the group, and the reason is just the same to that other chemical families. That's due to the increase in the number of occupied energy levels. So next we are saying they have high ionization energies. This because noble gases have a stable electronic arrangements. However, the first ionization energy of the noble gases decreases down the group, and this is due to the increase in the atomic size. So if you remember again, we have seen the ionization energy of alkali metal and also alkaline earth metal. In the side of the halogens, we have seen electron affinity. And both ionization energy and electron affinity were decreasing down the group, and the reason was due to the increase in the atomic size as the atomic radius is increasing down the group. So even here, ionization energy of the noble gases decreases down the group, just like alkali metals and also alkaline earth metal. And the reason is due to the increase in the atomic size, or due to the increase in the atomic radius as the atomic size increases down the group. So we're saying noble gases have low melting and boiling points. Why? This is due to the weak interatomic forces for attraction between the atoms. However, the melting and the boiling points of the noble gases increases down the group, and the reason is due to the increase in the strength of the force of attraction holding the atoms of the gases together as the atomic radius is increasing down the group. So we are saying noble gases are poor conductors of heat and electricity. This is because they have no delocalized electrons in their structure. Delocalized electrons are electrons which are responsible for electrical conductivity. Note, we are saying xenon takes part in some reactions due to its low ionization energy as it is high atomic number. Lastly, we are going to proceed to the uses of the noble gases. We are saying number 1, helium mixed with oxygen is used in deep sea diving, mountaineering, and for patients with breathing difficulties or breathing problems and those undergoing certain forms of surgery. Number 2, helium can be used instead of hydrogen in weather balloons for meteorological research because helium is unreactive, or it's inert, or it is stable. So number 3, we are saying helium is used in thermometers for measurements of very low temperatures. Number 4, we are saying liquid helium is used to keep certain metal alloys at temperatures low enough for them to become superconductors. Number 5, neon gas is used in streets and advertisement lights. Number 6, we are saying argon is used in light bulbs to provide an inert environment to prevent oxidation of bulb filament. And lastly, we are having number 7, argon is used to provide an inert environment during the welding of metals. That's arch welding. So learners, that's the end of our video today. Thank you.